Just going to start in a few moments, folks. Just a quick audio check. Hello everyone, welcome to the October edition of London GraphQL, hosted again in Kraken. Thank you very much to Kraken. Thank you for bearing with us. Our normal AV crew couldn't make it today, so Jem and I have been desperately trying to figure out how to do this ourselves, and we may or may not have had it work, so we'll find out when we try and watch back on YouTube later, but you know, fingers crossed, everything's sorted. As always, thanks to the various people that have made this possible. We've got GraphQL, who are Jem and myself, also on AV duty today. We've got Guildhost, who are our events platform, and of course, Kraken, providing this fantastic venue for us. Thank you to everyone there. As with all of the GraphQL events, they're governed by the GraphQL Code of Conduct. So essentially, be nice to everyone, be welcoming, and if you have any issues with anyone, you can bring those issues to myself, to Jem, to any member of the GraphQL Technical Steering Committee, and you can reach out on the email address there. If you want to stay in touch with us, which obviously you will, so that you can come to more awesome events, then our guild host is there, which is where you would have signed up for today's event anyway. You can also join us on the official GraphQL Discord server, where we have the London GraphQL channel. Feel free to post things in there, especially if you've got write-ups or anything like that that you want to share. We also have the main GraphQL account, which we are trying to do a better job of posting on, and also on LinkedIn as well. Just as an FYI, there will be a video of this coming on at the moment, and also people may be taking photos. If you do take photos of people, please be sure to get their consent before you post them onto social media or the internet in general. If you do share anything about this, please use the hashtag #LondonGraphQL so that people can discover it. And if you do share content, we'd love to hear about it as well. So tell us, email us, post it on the Discord, whatever. Tonight's event, we're running a little behind schedule. That's entirely my fault. We'll start with Stefano from American Express talking about their journey to the Federated GraphQL model. After that, we're going to have a little break again to eat some more pizza, talk to Stefano and everyone else about various things, and then we'll come back probably, I guess, 8:05. We're a bit behind schedule to hear Dan Starns on AI-powered GraphQL query generation. Then I'll do a very quick closing notes. We'll clear up, and then we'll head down the pub, which is the Adam and Eve, just around the corner. The London GraphQL Meetup doesn't do Q&A after talks. Instead, we all just form a group, and you can just chat and ask your questions there, rather than in this more, I guess, confrontational situation. So it's a bit friendlier, which is great. And we like being friendly. And we'd love to get some of you feeling that we are friendly and that you want to come up here and tell us your GraphQL stuff. So please, 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 if you're here today, we want to hear from you. Come submit a CFP. Tell us something about what you do. It doesn't have to be a long talk. If you want to just do like a 5-minute talk on a particular tool that you like, or tell us about how you're using GraphQL, or its strong points, its weak points, some technology you're excited about. Anything GraphQL related, please fill out the CFP. And if you're not confident enough to fill out the CFP, by all means reach out to myself, Jem, or anyone else from the GraphQL TSC or any other events related people. And we'll see what we can do to help you to gain the confidence to stand up here and present. We also want to mention that there is the big FOSDEM event in Brussels that's coming up at the end of January, beginning of February. And that is a absolutely massive open source conference for basically every open source project that you can think of may be trying to get a table there. It's completely free to attendees as well, which is amazing. So it's a really great event. We have managed to, with the help of another number of API technologies, get what they call a dev room there. So we'll be having a few talks in that dev room, which will be on the Sunday afternoon. We'd love for you to join us there if you fancy a trip to Brussels. And yeah, the schedule announcement will be on the 15th of December. CFP opened a few hours ago, so if you want to submit a GraphQL talk there as well, that would be amazing. I want to mention the things that I regularly mention, which is if you are one of the contributors to GraphQL, to one of the repositories, github.com/GraphQL/anything there, then please, there is a grants program available to you, so you can ask for some funding to help you to put some more time into whatever project it is that you're working on. And our next event probably won't be the 28th of January, probably the week before, so probably the 21st, but we're still playing that by ear at the moment because of FOSDEM. So keep an eye on the various social channels to find out what's happening there. And yeah, without further ado, I'll hand over to, I've forgotten who was the next, Stefano. So, Stefano.
It's on the right side. Come from the other side. Oh, that works better. How much time do I have? Half an hour, because we don't have question at the end. So means I can go slow. Hi there. Funny picture, no? I really loved it. And my name is Stefano. You can call me Stefano. I don't mind. I know English-speaking people, they say Stefano. And for everybody that doesn't know, I work in American Express, and if you know American Express, you can recognize the Centurion, which is on my side. And I am an engineering director in American Express, dealing with the GraphQL platform we are building in our company. And let's talk about the platform, because really talking about me is probably like boring, no? Starting point, 100+ channels in American Express. If you're not familiar with the concept of a channel, I mean, the channel is just an interaction channel. You can call it front end. So if you think about American Express as like the public website where you can log in as a customer and see whatever you can have on your card, my mobile app, which actually is over there, it's another channel. And why I say 100, because American Express is a very rich business. So in the UK, maybe you think just about cards, which is mostly true, but in other countries, we have banking services, we have loans, we have other things. Plus, we manage the network. So if you're a merchant, means you accept American Express. Well, that's actually another channel, because you don't go on the same place where Stefano as a customer, you as a customer go for checking your transaction. So 1 + 1 + 1 is more than 100. That's a quite sizable amount. And that's what you have on the other side, 3,000+ APIs. So common problem everywhere, APIs feeding data to channels. So how many troubles are we going to have here? Can anybody make a rough calculation? My rough calculation was like more than 1 million, no? Or at least 1 million, because 3,000 APIs for 100 channels. How that's possible? What's the cost of that? What's going to happen? Who's managing that? Yeah, 1 million+ problem. Actually, there is no plus, but probably I should have added the plus, no? It's an interesting problem, no? Now, everybody thinks that. You are overfetching, you are underfetching, you have n+1. I'm pretty sure it's true. I'm not going to say no, okay? Every time you go on internet and you Google for GraphQL problems in everywhere, it's underfetching, overfetching, and n+1. You always find that. I actually challenge you to do it after my talk and see how many times you see overfetch or underfetch in the first, 100 results, probably first 99. But this is what I see, no? It's a slightly different story or a slightly different problem. I have a massive problem with data governance. Everybody forgets about the data governance. My company is a financial company, and I'm pretty sure you don't want anybody to mess with your financial data. That's an interesting governance problem. Conflicting data, 3,000+ APIs for 100 channels. how many times do I have a duplicative field actually returning a slightly different information? I don't know, I didn't count, probably better that I didn't do it, but that's the problem, no? It's data-driven, because if you think about you have 100 channels and they have 3,000 APIs, here is everything like bottom-up, it's entirely data-driven. So who's deciding the customer experience? This concept of we need to design better or the best customer experience ever for every customer. No, I think even here in Octopus Energy, they spend, I'm actually trying to turn, but there is nobody there. They spend a lot talking about the best customer experience. No, I have a very good experience with my app, yeah, but if you want to do things based on the experience, it can be data-driven, because Stefano, the human, the consumer, the customer in this case, no, doesn't talk about data. Okay, I don't deal with fields. I deal with information eventually. Cost. Well, 3,000 APIs for 100 channels. I mean, who's going to pay for that? It's a massive problem, no? If you have an API and nobody's using your API, you can say, well, it's a Lambda function, so if it's not used, it doesn't bill. Well, that's the Amazon model. Okay. Who's managing code changes, vulnerability, just the upgrade? JavaScript here, upgrade a package in JavaScript. It takes 1 minute. Well, that 1 minute has a cost, no? Who's managing that? There is a problem. 3,000 API multiplies the cost on weekly, monthly, whatever basis. We got problem, no? And delivery efficiency, no? That's another interesting problem, because 3,000 plus API again. So how many times that's just a random assumption, my mobile app triggers a change in an API. Then there is, 6 months later, my website trying to trigger the same change on a different API. So where's the efficiency of this delivery? Why is everything happening in a way which is not like omnichannel, customer-centric? Keywords which I think are important, no? And because you're engineers, I assume, look the rotten layer cake, because it's Halloween also, no? So everybody knows, actually you can use a nice functionality of this pointer, which is, it's not enough, okay, the pointer. So SOR, you know what a system of record is, general concept. Then you have multiple layers of API, fantastic. There is no single company I'm aware of, even a very small company, even a coffee shop probably, that has a single layer of API. There is always like an encapsulation API, and the encapsulation of the encapsulation API. And then you go to the channel, but before the channel, the poor guy dealing with the front end has to be the famous BFF, because they get things they can't use. Their job is, I have a very nice UI, I need to show something here. I get an amount of stuff. I can't use stuff. I need my balance. Okay, so they start building those BFF. And 1, 2, 3, 3,000 APIs. We go again to back. We go again to that, no? It becomes a nightmare, no? Who's managing those BFF? Who's deciding, who's checking those information are fine, are correct? I could stop here and trigger like a lot of discussion, but I'm gonna go. So, see the problem, experience-driven, data-driven. Now you can take what you want. Do you think we should build based on experience or based on data? If the customer is the king, you get the answer, no? It should be based on experience, not on data. Because based on data, honestly, remove everything here. The UI can make a call, a SQL call literally to the system of record. Actually, why the system of record? Plug the database into the UI, no? How many are familiar with like, I'm actually thinking this, WordPress. PHP, MySQL is done. You don't need any API in the middle. It's fantastic. Then you break your MySQL, but doesn't matter, no? It's not a sustainable model. It doesn't work, and it doesn't help anybody to deliver the famous best customer experience ever. So how can we improve this with GraphQL? Because this is what we want to talk about, no? First, actually don't remember what I have here. Yeah. Our journey, more or less. 2021, investigate. Now, everybody skipped this phase, but my company is a kinda big company. I was literally reading yesterday, we are like tracking 76,000 employees. I can tell you is like 14,000 in technology. So it's quite sizable, and we cannot just decide, oh, Stefano woke up today and decide, oh, let's implement GraphQL. It doesn't really work. Even if I would be the CIO of a company, it doesn't work in that way. We need to think about that. So let's investigate. Ideally, we want something like that. If you are familiar with clean architecture, this is probably what you find on any book, no? And this is pretty generic. Let's not talk about clean architectures. Like, logically speaking, we want the channel, a GraphQL layer in the middle wrapping everything, and the backend. No details. It's more than enough. So you place a shield with GraphQL between backend and channels, producers and consumer. Okay, common concept. But how do we want to do that? Fixing the famous rotten layer cake, which actually is a bit stinky probably as a layer cake, you know? I want to make it funny because it's late for everybody. First layer, channels and presentation layer. Presentation only concerns. So the channel is a channel, we talk about that. Presentation layer is, in today's technology, particularly if you do web, server-side rendering. As an option, is presentation only. You don't have to think about your data, server-side rendering. I know somebody uses SSR for mobile, things like that. Don't judge, it's fine. Okay, but it's just about you deal with presentation. You can potentially even consider like kind of edge cache, because maybe you don't want to put on the client, you want to put closer to the client, still like there on the edge, essentially, no? Then we got the, is it the purple? I can't remember how we want to define the color of GraphQL, but we got GraphQL. Integration and choreography. Integration, everybody knows. Why? N+1. We can start with that. Choreography, we can talk a lot about choreography, but it's not really choreography in terms of event-driven services. If you know domain-driven design, it's not that. It's more about you make a query, something can go in parallel, something can go in serial, I can do some stuff, optimization really. Logically speaking, it's still choreography. APIs. Color scheme is important. We'll come to that in a second, no? Domain services. That's a blend. It's a new color. You didn't see that. Okay, it's a new color. But look, the blend includes GraphQL. It doesn't include the black of the system of record. When you go down, your data services. Doesn't matter. Data services are not going to disappear. If you manage or create like a system of record, you still have a data service. It's absolutely fine, okay? So nobody takes the data services anywhere. But down. Experience-driven and simplify data-driven. So, well, that's a weird slide, but you see there is a radical difference from the other one. Now it's driven by the experience, and the experience drives down close to the system of record, because we need to take a decision. Are we trying to design our system based on what our customer needs, which is also a reflection, a projection of what our business needs? Or are we trying to design our system based on essentially what the database can do? Okay, it's not what we want. This moves to 2022, startup mode. Now, that's a funny thing, but I love to say startup mode. Actually, I borrowed for somebody else, but startup mode because, okay, yeah, fantastic, architecture is sold. How do we get consumer? Now, my company is big, and you might probably not figure that out, but I can come with a new cool technology. I need to find somebody that's going to use it. Otherwise, it's like I switch it on today and switch it off tomorrow. So how to build a schema that lasts? That's probably the most important slide for me, because really, everybody knows you build a schema, you evolve your schema. Change management GraphQL is an interesting thing, painful in my opinion, but it's possible. Change management on a REST API is a nice thing, could be painful, probably slightly better than GraphQL, but still possible. But really, like when you create a new skyscraper in London, no? There is a thing you can make wrong, which is the foundation, because you can potentially change your foundation later. If possible, it's going to cost you millions, if not even more than that. And really, it's never an option. So you need to know from day zero how many stories you're going to have, and if you need to have like the helipad on top or not, things like that. That's not going to change. So it's a one-off decision. And the same is for the schema, no? Because you need to put some grounds on your schema. You cannot think to go in startup mode, you design a schema, you try to get some consumer, and literally in a few months' time, oh, by the way, we are deprecating 50% of the schema, you need to change your queries. Because those consumers will probably start yelling at you. It doesn't work in that way. Some grounds needs to be there. So how do you really do that? Puff. You can start thinking about a domain model based on journeys. What is a journey? It's a customer journey. I omitted probably the word, but it's a customer journey, no? So it's experience driven. You go on your UI and I am a customer, I want to log in, I want to see some data, or even better, I am a customer, I want to log in, I want to see my address, change my address, send my new address, things like that. It's all based on customer journeys. When you start doing that, this is not Amex, it's just generic, but any financial company more or less, no? You start pinpointing, you have some important artifacts coming out, transactions, I can't remember, account, merchant, customer, blah, blah, no? If you're familiar with domain-driven design, that's like the foundation of a domain model. We're not doing anything weird, but the only important thing is the dimension of this domain model, actually the driver, I would say, of this domain model is the experience. So that's really the way to look at this. And it's important because when you do this, you also start looking at the famous bounded context. I'm introducing a lot of DDD concepts here, but bounded context. Now, those could be fake probably. Actually, they're not because account and transaction, they could be the same. Merchant and customer are actually the same and blah, blah, blah. Very important. Why? Well, give me 5 minutes. You're going to figure out why. So you do that and you start doing what? You find bounded context, ubiquitous language, and aggregates. Ubiquitous language is important because the last thing you want to do is to start creating a model where you have like, I don't know, type TXN, sorry, in English, and nobody uses that word. It's a nice acronym, actually not even a good one. Everybody says transaction. So if that's the language of your domain, it's the language which is spoken by people building UI, why do you want to call it in a different way? You're just making like a very bad developer experience. The only thing you're going to get with that is people asking you to join a call every time to understand something which is probably for you, who did the wrong design, very simple. For them, it's a nightmare because I have 1,000 people designing UIs. They all think it's transaction, but we call TXN. It doesn't work. So you start pinpointing those things, and they all end in your schema. Now, you got a schema, okay, fine, that's nice. Actually, you got also some consumer, it's important, okay. Then you go into the, I went into 2023. Scale, is it scale? Yeah, I'm scaling, no? So I'm hooking up some consumer, I'm hooking up the thing which matter probably to me to get some consumer reading my model. So, oh yeah, there is a value in your new API. Yeah, fantastic. Okay, can we do more? Of course we can. How? Next one is, voila, how to complete most important journeys. Because you can have a type transaction, you can have a type account, you can have what was the type customer. Yeah, they're still generic. Probably they suffice some read, but there is no UI which is complete with a read model. Every UI has a sort of read and write. Now, if you love domain-driven design, we talk about CQRS, which I think really fits well in a GraphQL model because read and write are technically separated, but even without that, the important thing is you complete a journey and you deliver a value. Because if you can just read my name from the system, well, yeah, the value is a lot limited. And somebody could say you, in your 3,000 plus API, I have 100, they're giving me your name. So why the 101? That's a good point, actually. Difficult to debate, you know. So how to complete the most important journeys here? We need to extend the initial concepts to entities, value objects, and operations. Okay. Now, entities, GraphQL, so it's something with an identity. Let's make it generic for this talk, and it's fine. Value objects, or actually value types, somebody will come to that in a second, but we have the same thing. So, I don't know, pick up random stuff. Type country includes a code and a name. That's a value type. It doesn't have a key. Don't tell me the country code is a key. Well, potentially it could be, but really that's not. The address is a value type, okay? It's just a collection. We decide it has line 1, 2, 3, 4, 5, how many lines do we want, a postcode, and again the country and the province or the state, or it depends, no? Subdivision is the ISO verbiage for that. Operations, yeah, queries, but the queries are fine, no? Customer by customer ID, that's a very easy query, or like a transaction by transaction ID, very easy. You want to complete also your mutation, because the mutation is what gives you the complete power to enable an end-to-end journey. I log in, I see my data, I change my data, I log out. If you can enable all of them, or a subset of an end-to-end journey with GraphQL, you really hook your API into a UI, because that journey is completely delivered by my GraphQL platform, and that's the important thing. And you need to complete all three things. This moves to a fix we had to do, and probably everybody has to do, introducing domain services. You remember the blend of the purple color, was it purple? I don't know, in my previous slide. No, domain services are not data services, because the data service just exposes me what? Select star from, it's a database. If you use Couchbase, it's slightly different, but as the same concept now. That's not a domain service. It's not a service, full stop, not even a domain. So a domain service is something, domain-driven design would say, actually, I don't have it, okay. Domain-driven design would say a domain service is a service that really satisfies a business operation, applying all the rules, all the checks, and everything that needs to be done for completing an operation, business operation. This is what we want. So we don't talk about, or we're not really talking about how many domain services do you want to have. That's an implementation choice. You can have one domain service for changing all the customer data, or a service, but potentially per operation. Pros and cons. Cost is normally the cons there. It's always a problem, I know. But it simplifies a lot, because now we get the customer journey, we get the mutation, apply for a new card. I was actually using a wrong example before. A domain service, the domain service takes the input, is like one-to-one, and manage the call with all the backend services. The difference between GraphQL is GraphQL shouldn't have any logic. So when you run a mutation in GraphQL, GraphQL can do the n+1, can decide to call service A to get a key and then call service B to use that key to fetch additional data. It's absolutely fine, but a domain service does more, the famous business logic. Because unless you want to put the business logic into your GraphQL layer, and we can talk about the benefit or the drawbacks of that, really the GraphQL layer should not be in charge of a domain logic for multiple reasons, starting from who's owning that. The business logic is a very internal and intimate thing of a system of record. So again, if it's experience-driven, down, shift down. GraphQL service should not be into that, should have no understanding of any logic for validating my name, getting a new card, where do you have to live when you apply for a new card, or things like that. I don't know about that. I only know there is a service over there that, given some information as an input, can tell me as an output, you got a new card? No, sorry, you don't get anything from here. Fantastic. The logic belongs to somebody else. And even from an organizational perspective, who's the product owner, for example, owning the logic? Well, it's the one working the backend. It's definitely not the one working the domain service, and not even the one working the GraphQL layer. So it goes down. The domain service does that experience to data service translation, which is much needed. And why not doing it in GraphQL? Well, in theory, you can do in GraphQL, but then we should talk about, do we really want to have logic in GraphQL? Do we really want to have fat resolver in GraphQL instead of lean function? Very simple call. Actually, in many patterns, you see like the resolver is calls a lambda as a very simple thing. Well, if you start moving any logic to the GraphQL layer, that's not going to be possible anymore. So you need to take a decision. Really, my decision is down. System of record, you own the governance, you own the data, you own the logic. I don't want to know anything about what you do. Just an answer. Can I get a new card if I apply? Yes or no? Because this is what you have to give to the customer. Everything else, the customer doesn't care. Experience-driven, data-driven is not there. And the bit important here is every journey is reusable. So if you create one time a fully enabled journey with GraphQL end-to-end, apply for a new card. Now, website, mobile app, actually Alexa is a channel for American Express. I don't think you can apply for a card using Alexa, but it's a channel. Done one time, done forever. It works on any channel. You deliver one time, and the effectiveness of this delivery is for everybody. So the paradigm of the omni-channel, which doesn't belong to GraphQL, but belongs to anybody trying to deliver in a company that has more than one UI, is important. And you do it nearly for free with this model. So last one, Federate. Also because I'm ending out of time. Well, for federation, you got two problems here, no? I got two problems, technology and organization, no? Now, technology, it's an easy one, if you think, because entities, value types, and ownership. If you know the famous directives, keys, provides, things like that, well, I did domain-driven design until now. So the entities came for free because I already found where there is a key, where there is no key, who owns what. Value types, I already identified them. So they're coming for free. What I'm doing is probably adding a directive to the schema. I'm not doing any more work rather than that. Ownership, well, when I did my schema that last, I already identify who owns what because it's part of bounded context. It's part of the very first draft of the domain model. It's coming for free. I'm not trying to open again another box for the same things. It's already there. Easy peasy, no? Organization, well, that's a different problem because every organizational problem is a different problem, no? Now, clearly, the number of subgraphs is a problem. One driver is, if you apply domain-driven design, maybe one subgraph per bounded context, and makes sense. Can you have more than one? Sure you can. Can you have one per entity? Well, I think you are like excessively splitting your graph. It's a point of view. Here, case by case can be completely different. But logically speaking, a bounded context works pretty well. Bounded context is probably tied to a single SOR, to a single part of the organization that deal with that. Customer is customer. It doesn't matter if I have two systems of record for customer, maybe one for individual and one for legal entities. As a single bounded context with a single legal, with a single part of the organization owning it, it makes easy, no? Ownership, well, we talked about that already. It's already there. Governance, well, this is probably you're not going to fix any time, but you start applying some good pattern because first of all, with this, you have already cut out all the duplicative fields. You don't have anymore 25 APIs, thanks to domain services, which are delivering the balance, no? Okay, there is only one API giving you the balance, and regardless if that's correct or not, it comes from a domain service, which is in charge of calculating the balance. So you start addressing the governance. Governance is many things, and I mean, we can talk for ages about governance there, but you see, comparing with the starting point, well, this one has provided what? Well, I don't have a percentage. 50% of the fixes you wanted, there is a sizable 50% you still have to address, but it goes in the right direction at least. And what? The last sentence, or probably the one before the last, is this one. Because you apply domain-driven design and because you are now trying to slice and dice your subgraph in a good way, any organization that designs a system defined broadly will produce a design whose structure is a copy of organization communication structure. Conway's laws. Melvin is the name. I don't know if you know this principle. You can probably think about if this principle applies to your company. It's quite proven, I guess. And guess what? Bounded context, subgraph, organization. We say that. Maybe you can probably do on the other side. So given my organization, how many subgraphs I'm going to have without creating any GraphQL. Well, you can probably reverse engineer that. I think actually that's a good job to do if you think about GraphQL federated tomorrow, because it might be interesting to know whether, before you start the journey, am I going to end with 1, 5, 50 subgraph? Well, 50 probably is a very big amount, but that's fine. This one is useless, because we're going to talk in a group in a second, and I'm probably running over of 2 minutes, 3. That's fine. But OK, that has been our journey. So a slide which is not here, oh, thank you, is we normally apply consistently domain-driven design to most of the things we do. Backend design, so designing a system of record, which is probably where domain-driven design is normally used, I agree, but also GraphQL. Have we found a value? Or actually, yes, a lot. Because trying to put people together like the famous, depending by the approach you use for domain-driven design, like those who have questions and those who have answers, you put them together. And coming out with a draft or a foundation of a GraphQL schema in literally, not kidding you, 1 day is absolutely doable for a company like my one, and Kindersure for a company like your one. And it provides a massive value because, again, try to think, you get into this journey and you make wrong the foundation of what a customer is, what an account is. You're going to have a problem. You're going to undermine immediately the stability of what you have done. So the marketing is sometimes important as well, no? Because the problem is consumer, they don't want any disruption. So you can deprecate a field, ask them to move to another one, this is all fine, okay, but the less you touch the schema, the better. Resolvers, they don't care, because really, they don't see if the backend is changing and now you wire the resolver to a different backend API. It's one of the points of GraphQL, no? They don't have to know about that. You keep running the service to them. It's none of our business to know the SOR has evolved and now we move from an old mainframe, for example, to a new distributed system. Doesn't matter. Can I get my balance when I give you my card number? Yes, you can. Fine, fantastic. So you start segregating the flow of a conversation, which normally is like top-down, bottom-up, is vertical, no? Every UI wants to talk with every SOR and vice versa. It's an organizational nightmare. You just tell the UIs, guys, any request, place it to the GraphQL layer will make it available, well, eventually in the future. Backends, your business, guys, is just to make the best system of records ever for our company. Do it. You're not going to be disrupted by somebody in the UI coming and beg you because they have a field that doesn't tick very well on their UI. You don't even understand what a UI is because maybe you code like application, data-intensive Java application, and somebody comes to you and talk about React, and what's that? Well, I know in the area of full-stack engineers, everybody knows about that, but it's always a possibility, no? Fix it. And I mean, my experience is it's a model that can work because it can scale it pretty quick. If you invest at the very beginning in understanding how you can lay an enterprise end-to-end GraphQL layer without rushing it, like, oh yeah, let's make a POC and let's do the usual thing of the POC now has become like the productional foundation. That's like gambling the system. All done. It's a nice blue. Oh, wow. Oh,
thank you. Thank you, Stefano. That was brilliant. And as always, repeats that message that resolvers are just and the schema is just a thin layer. And this is where GraphQL originally came from, right? Within Facebook, they already had all of these data services. They already had everything else. They wanted a better way to enable their multiple clients when they introduced mobile into things to be able to consume this same data in this domain-driven structure. And so, yeah, absolutely critical to think of it in that way. Resolvers should really not do very much at all. It's one of the mistakes that I do see people making. Resolvers should be really small. Put all of your business logic in that domain layer. Very well done. All right, everyone, if you want to go grab some pizza, maybe ask Stefano some questions, and we'll come back for about 5 past. Thank you.
APIs because the domain folks do that already. But we are just maintaining that thin layer, but it's still quite complicated. Yeah, if you are interested in our technologies, GraphQL, APIs, sustainability, climate change, and all that kind of stuff, please reach out to me, and I'm more than happy to talk to you. And thank you very much.
Okay, so next up we have, of course, Dan. Dan, if you'd like to take the stage.
Hi, everyone, again. So I'm Dan, as Benji mentioned. Thank you for coming, everybody. It's a big part to come and join the community today. And the slides aren't up. Let's give them a go. Thank you. Cool. So I'm going to be giving the talk today about AI-generated GraphQL queries. And just a little bit about myself. You might have found me on the internet, hacking around on things, working on open source projects, and building GraphQL communities around the world. So GraphQL generated, AI-generated GraphQL queries. I'm going to go through a couple of steps today in this slides. I'm going to show you the library that we've generated. I'm going to show you how to take that to a production level using RAG. And then I'm just going to show you like some edge cases and some security vulnerabilities around generating your queries with AI. So it's going to be a bit codey today. I've got some TypeScript code, so hopefully I'm not going to scare some of you all off. But essentially, I'm going to be showing you a NPM library that we've been building that's going to let you generate some queries. So essentially, it starts like this. This is some TypeScript code, and I don't think the pointer works. But essentially, you start with your schema. So you can see that I've provided just a very basic schema into our GraphQL plain text client, or GQLPT. And then essentially what you can do is you can call this function called generate query and variables. And this is going to build a big prompt based off of the plain text that you give it and also the schema. And then it's going to send that to a large language model and then pass the response and then give it back to you something that looks a little bit like this. So essentially you can just say like, find all the users in my API, and it's going to give you the relevant query based off of the schema that you've got. There's two methods on the library. So you can call the generate query and variables, and you can also call the generate and send. And the generate send is just going to proxy it through to the API that you specify. So I have a demo. Let's just get, hopefully the demo gods play well with us. So I have this repo called Talk to GraphQL, which I highly suggest you go and check out after this talk. And I have it cloned down here. Zoom in. And in this repo, we have a schema. So this schema contains just basically some users and logins. It actually only has 2 queries on it, so it's quite short for demonstration purposes. And what I want to show you is how to configure your GQLPT client using this schema. So I've just like imported the schema from file, and then I'm just passing that raw GraphQL schema into GQLPT. And then I have like 2 functions that are called in this file. I have find all the usernames, which is essentially finding all the usernames. And I have find all logins by Alice as well. And I log them. So we can run that. And what that's going to do is it's going to take the type definitions that we gave it and the plain text query. And you'll see that Alice's logins, she has 2 logins. And the usernames are just 3 usernames. And I can change this around. So if we have a look at our local schema, we have a couple of other filters, like, for example, a date filter in here. So maybe I want to find all the logins, if we just get rid of everything. And we'll say, find all the logins between a date. So find all logins between just 2 random days, doesn't really matter. And then let's log that result. In fact, what I'll do is I'll pick 2 of the dates that are in our schema, and we have just like a bunch of dummy data up here. So I'll just pick like the 15th to the 17th. There we go. And let's run that. And you'll see that it's given us the 2 logins and it's generated the filter for us. And just to check out what that filter looks like, I can say generate query and variables. And we'll log that again. And you'll see that it's generated like some form of query that has the arguments inside of it, and it also has the variables for us as well. So it's just generated that query from the plain text prompt that we've given it. GQLPT also goes a step further. You can use local schemas and you can also use remote schemas. And in one of my examples here, I have a remote example. And instead of passing in the type definitions to our client, this time we're just passing in some headers and a URL. And this particular API that we're working with is the GraphQL, GitHub GraphQL API. So I'm talking basically going to be able to speak plain text to GitHub. And in our remote example, I have 2 queries. The first one is find the latest issue on the GraphQL JS repo. And the second one is find the star count of the GraphQL JS repo. And then that's just going to resolve those for me. So I can run that. And it's going to take a little bit of time. And I'm going to dig into a little bit more about vectorizing and RAG later on in this talk. But the GitHub GraphQL schema is huge. It's maybe 300 entities inside of it. And so each time we run these functions, we're essentially going to have to send the schema along to the large language model each time with us. But I can run it anyway, and you'll see that it takes a long time, and it will prove to you why we might need some vectorization later on in this talk. Whenever that runs, it will run. Here we go. So that the latest issue on the GraphQL JS repo was something, maybe if we can find it, the body, CLA bot is there. But just to confirm that this like actually works, like GraphQL JS. Oh, GraphQL JS. Let's see that. Is it? Was it a pull request? Closed. Say again.
It'd be a comment I expect on a pull request.
Let's have a look. Oh yeah, it's a comment on an issue. Let's have a look what we're seeing and how we could. Yeah. Well, the star count will be somewhere close. I mean, they do round up the star count in the UI. So what does it say there? And what does it say there? Okay. I'm not sure exactly what we're seeing here. It seems like a really weird issue. Like the title is that. So I'm not sure what that is. Maybe a bug. We'll just gloss over it. Anyway.
It could be one of these GitHub bots that have been plaguing us recently. GitHub doesn't let you see it, so I'm surprised it comes through the API.
Oh, there you go. Okay, so we've had a little demo about GQLPT. You can install it from npm. Let's just dig into a little bit about how it works. And as I said, essentially it just builds one big massive prompt and then sends it to the large language model. And it looks a little bit like this. So you essentially inject the type definitions that you have, and then you inject the plain text, and then just some query generation rules. So in our open source repository, we have just like a bunch of query generation rules that you can add stuff to, and it will just get appended to each query. The type definitions, we compress them, because essentially if you have a very large schema, we're going to go over a lot of the character limits of these large language models. So we just basically get rid of all the white space. There's not really much we can do there at this time. The plain text, again, we just inject that into the prompt, but the library actually has some caching in there for you as well. So you can cache the responses, and the second time that you run the query, it's going to be a lot faster for you. And finally, just all the rules. So these aren't like the real rules, and you can go and check out all the rules that we have on the GitHub repo, but we just like append these to the prompt and then send it along to the large language model. So, you know, like use variable names, use fragments, or define the variables. We had some issues with subgraphs recently, so we just added some rules for traversing the subgraphs in the correct way. And then we just pass the response. But you're probably thinking, you know, it's just a plain text string. So you're not really going to be able to get any TypeScript inference from that plain text string. And this is where GQL-PT CLI comes in. So the CLI will essentially scan your code for the generate and send methods. And if that exists, it's going to actually generate the TypeScript types, and it's also going to generate the query for you at build time. So that at runtime, you're just reading from disk, and it's not even talking to the large language model. And as I said, what it does is it looks for the string using static analysis, and then it will actually write the types to your node modules directory. And I can show you that. So I have my local example. Let me just get rid of everything. Okay, so we have our local example. And what you notice is that, you know, when we find all the usernames, there's no response type. And that makes sense because it's like a random plain text string that we don't know anything about. But in the package.json of this demo repo, you'll see that there's a generate command here, and it just runs npx GQL CLI, and it gives it like the location, which is our local file, and then the schema. And so I'm going to run that and bring up the local file. Let me just get rid of everything. So local. And now if I come and hover over this, you'll see that, you know, all of the response for all of the usernames actually has a type. And the same for the logins for Alice has a type. And the way that that does that is if I go to the node modules folder, and in the build, you'll see that there's a types TS file. And basically it creates like a map of the plain text query, and then also the TypeScript type beside it as well. And alongside these types, it also generates basically like a query cache, essentially. So you can just like build your GQL-PT instance at build time, and then at runtime, it's just going to read these static queries from disk. And just to show you working on a larger scale API, we can also generate for the remote API. So this is the GitHub API. So I just run the same script, but for remote. And it may take a second because it has to send the entire GitHub schema to the large language model. Didn't take too long. But you'll see, find the latest issue of the GraphQL JS repo. You'll see that now it also gives us like the correct types. So basically, any GraphQL API that you can come along with, it will generate the queries and the types for you. and this one as well. There. So that is the CLI, the client and the CLI. And now to some of the juicy bits, which is the schema size. You know, if we're working with the GitHub GraphQL API, as I said, it's 300 entities big. We're quickly going to be consuming our tokens on whichever large language model we're using. Not only that, it's incredibly slow. This is just like a snapshot of the GitHub API, and you can see that it's already very big. And so there's a solution to this in the AI space, and this is called vectorized embeddings and RAG. And essentially what we can do is we can take our GraphQL schema and we can visit it, and we can store it in a vector store. For the purposes of this demonstration, I'm going to show you how to use Neo4j. And essentially, you create a binary representation of each type in your GraphQL schema, and then you store them in a graph. And then when you want to search for a particular query, you essentially give it the plain text string, which is in the top left corner. You use some Cypher, the query language from Neo4j, and you use their graph data science libraries. And it will essentially compare the vector of the plain text string against all of the vectors that you already have in your database. So you can see here in the highlighted in yellow that from finding all of the usernames, before I actually talk to GQLPT, I'm going and grabbing a subset of the schema that's relevant to my query. Then once you have that subset, you can basically pass this directly into GQLPT as you would just a normal type definitions, normal schema, but it's going to be maybe a fraction of the size because you've already leveraged your vector store to reduce the size of that schema. And I can just show you like what that looks like. I vectorized, it takes a long time to vectorize large schemas. And I was playing around earlier, you know, uploading the schema that we have. And I do recommend you go to this repository if you're interested afterwards. But this is how we upload. You know, we visit the schema, and then we basically create like some vectors and then create relationships in the database. And I have something here in Neo4j. If I just return everything, you'll see that this is like our demo schema, but vectorized in Neo4j. And you'll see that somewhere in here there is actually a query. So you'll see here we have like users and logins. And there's a very particular property on each node, which is the vector, which is like this huge binary form here. And what we do is we search the vector store for our plain text string, and then it will automatically compare the binary representation of the plain text string against all of the vectors in the database to see what's similar. And then in the query side of things, you basically match the nodes that are similar to your plain text query. And then I'll go over this, but you essentially create like a partial schema and then pass it directly into GQLPT client, and then that sends it off to your large language model, no problem. Okay, so you've learned kind of what is GQLPT, how to download and install the client, how to generate types, and how to take, you know, generating GraphQL queries to production level with AI. So thank you very much for listening, everybody. I hope you enjoyed my talk. Thank you.
Thanks, Dan. That was brilliant. I especially liked that it looked very much to me like that file with all of the queries in it. That looked very much like trusted documents to me. It is pretty much yeah. Everyone knows. Big fan of trusted documents. You should all be using them, most likely. Okay, fantastic. So, closing notes. I just want to say thank you again to everyone who has helped make this event again happen. Last one of the year. So thank you everyone for coming. Thank you to Kraken again for hosting. If there is any pizza left, please feel free to take it. We'll be cleaning up and then heading down to the pub. Again, I'd love to have more of you folks up here on stage telling us about your awesome GraphQL experiments, or your use cases, your stories, everything. Thank you again to the speakers. What am I missing? Adam and Eve is the name of the pub. We've probably got about, I would say, well, about a quarter of an hour here. We'll tidy up in the background, and then in about a quarter of an hour, we'll head out down to Adam and Eve and see some of you, all of you there. That would be great. Awesome. Thank you very much, everyone.